Paul Dirac's life began under a subtle pressure. Born on August 8, 1902 in Bristol, a British industrial hub filled with a sense of metal in the sea, his childhood home felt more like a rigorous classroom than a nurturing haven. His father, Charles Dirac, a Swiss immigrant and a French teacher, mandated that French be spoken during dinner. The rule was unwavering. Any English from Paul would halt the conversation immediately. Silence was used as a corrective measure, yet for a naturally reserved boy, quiet was already his default setting. His mother, Florence, of English descent and with more gentle nature, attempted to soften this rigidity, but the household dynamics were undeniably controlled by the father. From the start, Dirac existed in a duality of worlds. His father's discipline, taciturn continental logic, contrasted with the more relaxed, pragmatic British environment outside. He quickly understood the potential risks to language. Unless you could articulate something flawlessly, it was better to remain silent. This principle solidified into a defining characteristic. It was later jested that Dirac kept his words locked away like precious gold, dispensing them sparingly when absolutely essential. Behind the humor lay a fundamental truth. His upbringing had conditioned him to regard language as a high-stakes endeavor. Dirac was not a solitary genius in conventional romantic sense. He had friends, classmates, and interests, but his inner world remained intensely private. He cherished solitary walks, where he could think in extended, uncluttered sequences. He excelled in mathematics and physics at school, yet he rarely engaged in social competition, choosing to listen more than he spoke. When something in the world seemed illogical, he experienced an internal restlessness until he could impose order upon it. He initially pursued engineering at the University of Bristol, a practical decision influenced by post-World War I Britain and his family's need for financial security. He learned to analyze structures, forces, and how material behave under stress. However, engineering felt to him like a tool without a proper handle. It could certainly build things, but it didn't delve into fundamental reasons behind nature's behavior. Upon graduating in 1921, Dirac faced a dismal job market with virtually no opportunities. This economic downer nudged him toward the abstract realm he had secretly always favored. He stayed at Bristol for a second degree, this time in pure mathematics. During those years, he discovered his true means of expression. Mathematical symbols didn't criticize his accent, nor did they demand trivial conversation. They were exacting, but their exactness was impartial. He immersed himself in geometry, algebra, and the burgeoning field of tensor calculus, which Einstein had recently employed to formulate general relativity. Dirac began to realize that if the universe possessed a skeletal structure, mathematics was the key to accessing it. In 1923, he secured a scholarship to Cambridge, specifically to St. John's College, thereby entering the sphere of influence of Ralph Fowler, a theoretical physicist who would become his mentor. Cambridge in the 1920s was a place where ancient buildings housed radical new ideas. Classical physics was crumbling. The atom, once conceived as a miniature mechanical system, was evolving into a conundrum of quantum leaps and probabilities. Across Europe, a revolutionary theory was emerging: quantum mechanics, poised to reshape our understanding of reality. Dirac arrived at precisely the opportune moment. He lacked the flamboyance to draw attention or the eagerness to participate in popular debates, but he possessed something far rarer: a mind that revered structure so profoundly that it could create new structures when a theory required it. In 1925, Werner Heisenberg published a groundbreaking paper introducing matrix mechanics, an unusual algebraic system where observable quantities were represented by arrays of numbers rather than simple variables. Many physicists found the paper incomprehensible, like a foreign language composed of smoke. Dirac, however, experienced a surge of excitement. He didn't perceive chaos, but a new grammar struggling to take form. Within months, he produced his own revised formulation. Dirac recognized that Heisenberg's matrices were not arbitrary constructs, but integral to a more profound mathematical principle. He introduced what we now refer to as the canonical commutation relations, demonstrating that quantum mechanics possessed a structure akin to classical mechanics, except that the variables did not commute in the same way as classical numbers. With a single stroke, Dirac translated the new physics into a clear, universal framework. Those who encountered him during this period described him as strangely composed, even though he was working on the very forefront of physics. It was as if the external revolution was turbulent, but within his mind, everything was falling neatly into place. The following year, Erwin Schrödinger introduced wave mechanics, depicting particles as waves governed by a differential equation. For a time, the field diverged into matrix mechanics versus wave mechanics, two competing perspectives. Dirac immediately recognized that this was a false dichotomy. He proved that the two formulations were mathematically equivalent. The dispute was not between two distinct truths, but between two different dialects of the same underlying truth. Again, Dirac assumed the role that suited him best. Not a battlefield commander, but quiet architect who brought coherence to the map. His power stemmed from his appreciation for beauty in equations. Dirac believed that the correct laws of nature should not only align with experimental data, but should also appear inevitable. They should exhibit symmetry, simplicity, and an inherent harmony. This was not mere aesthetic preference. It was his guiding principle. When he failed to see beauty in a theory, he suspected it was incomplete. When he did see it, he trusted it implicitly, even before experimental validation. Such trust can be risky in science, but in Dirac's case, it became a source of remarkable accuracy. By 1927, he had formulated the first complete quantum theory of radiation, explaining how atoms emit and absorb light. This work introduced the concept of quantized electromagnetic fields and laid the groundwork for quantum electrodynamics. It also yielded one of the most celebrated results in physics. Dirac derived Einstein's coefficients for spontaneous emission directly from quantum principles. In Dirac's hands, light ceased to be a classical wave and transformed into something stranger, a field containing hidden particles within it. At just 25, he was becoming a pivotal figure in the quantum revolution. Yet, if you pass him in a Cambridge hallway, you might not even notice him. He dressed unassumingly, moved silently, and maintained a sparse social life. People would invite him to tea only to find that conversation didn't flow easily. He avoided gossip, drama, and any statement he couldn't render precise. If a question was superficial, he would respond with silence. If it was profound, he would answer with a few words that landed like polished stones. But beneath that reserve, Dirac wasn't cold. He was simply attuned to a different frequency. His emotions were genuine, but they moved slowly, like tides beneath a gray sea. When he admired someone, his admiration was intense. When a problem captivated him, it illuminated his entire inner world. His friendships, particularly with other theorists, were often conducted more through papers and blackboards than through casual conversation. He enjoyed long walks with individuals who would think alongside him without filling the air with unnecessary noise. In 1928, the story reached its first major climax. Though Dirac himself wouldn't have phrased it that way, he was grappling with a fundamental problem in modern physics. Quantum mechanics worked flawlessly at low speeds, but was incompatible with Einstein's special relativity, the theory that governed objects moving near the speed of light. Two pillars of the century stood side by side, yet remained unconnected. Dirac sought a single equation that honored both, not a mere fix or compromise, but a single, elegant law. He immersed himself in the mathematics, much like a composer refining a melody, gradually revealing the appropriate symmetry. The result was a Dirac equation, a relativistic wave equation for the electron. It was elegant, linear, and unlike anything that had come before. It not only merged quantum theory with relativity, but also predicted something startling in its own right. The electron possessed an intrinsic spin, and the theory implied the existence of antimatter, particles with identical mass but opposite charge. When he first wrote it down, Dirac wasn't seeking sensationalism. He was pursuing beauty. Yet, in this instance, beauty had consequences. The equation was a gateway to a new dimension of reality, and the scientific community was about to step through it. Part 1 concludes here, with Dirac in his mid-20s, almost silent in personality, yet enabling the universe to communicate in a new language. He has constructed a bridge between quantum mechanics and relativity, and caught a glimpse of antimatter as a ghost within the algebra. The following part will explore how that ghost materialized, how Dirac achieved global recognition, and how a peculiar quietness shaped the way physics learned to trust elegance. The Dirac equation descended upon physics like a flawlessly cut gem dropped into a stream. It didn't create a splash, but it subtly altered the current almost immediately. In 1928, Dirac was just 26, still reserved, still wandering the streets of Cambridge as if he preferred to vanish into mist rather than be noticed. Yet his single equation had accomplished three remarkable feats simultaneously. It reconciled quantum mechanics with special relativity. It elucidated electron spin without requiring additional assumptions, and it suggested that nature permitted negative energy solutions. That final attribute struck many readers as a flaw. To Dirac, it appeared as an opportunity. The negative energies presented a problem because they seemed to imply that electrons could continuously descend into lower and lower states, releasing infinite energy, rendering matter unstable. Dirac's initial reaction was not to modify the mathematics to eliminate the issue. His instinct was to have faith in the beauty and to inquire how reality might be structured to align with it. He proposed a bold concept. The vacuum is not empty. It is filled with an infinite sea of negative energy electrons. Because all those states are already occupied, ordinary electrons cannot fall into them, thanks to the Pauli exclusion principle. But if sufficient energy is applied to eject one electron from the sea, it leaves behind a void, and that void behaves like a particle with the same mass as an electron, but opposite charge. This was, in essence, the prediction of antimatter. Dirac didn't frame his idea in dramatic terms. He presented it in the clean, minimalist style he favored, as if it were almost self-evident. But to everyone else, it was shocking. The universe's equations had just informed physicists that every particle might have a mirror twin. Many were skeptical. Dirac initially contemplated whether the whole might be the proton, given that protons were positively charged and already known. However, the masses didn't match, and he realized the theory necessitated an entirely new particle. In 1932, Carl Anderson, while studying cosmic rays in a cloud chamber, discovered tracks that resembled electrons but curved in the opposite direction in a magnetic field. The particle was real. It was named the positron. Suddenly, Dirac's abstract seed transformed into experimental fact, and his equation acquired an almost magical reputation. It had not simply explained the world. It had foreseen a previously unknown aspect of it. For a theorist who seldom smiled in public, this was a subtle triumph that resonated powerfully throughout the scientific community. Fame arrived nonetheless. Dirac received invitations from across Europe, and his social circle expanded, whether he desired it or not. Yet he remained Dirac. At conferences, he could sit through an entire dinner without uttering a word unless directly questioned. Then, he might deliver a single sentence that concluded the debate with surgical precision. Colleagues learned to value his silences as much as his words. When you asked him something, you had to be prepared for the possibility that the honest answer was nothing. His closest friendships were with people who could coexist within that quiet. Niels Bohr admired Dirac's purity of thought, even if he sometimes found the man himself impenetrable. Werner Heisenberg respected him as a peer who could perceive the structure of quantum mechanics from angles that eluded others. And there was Wolfgang Pauli, whose sarcastic brilliance formed a humorous contrast with Dirac's austerity. Pauli would tease him. Dirac would blink, unfazed, and respond with dry remark that somehow transformed the teasing into a compliment. Their differences made their conversations oddly productive, like flint striking steel. In 1930, Dirac published the Principles of Quantum Mechanics, a textbook that resembled less a conventional textbook and more a blueprint for a grand cathedral. He introduced the elegant Bracket notation, psi and phi, transforming quantum states into objects that could be manipulated with almost geometric clarity. The symbols now seem indispensable to every physics student, but at the time, they were revolutionary. He also formalized the concepts of operators, commutators, and transformation theory in a way that provided quantum mechanics with unified, almost philosophical backbone. The book was not conversational. It didn't attempt to reassure the reader. It assumed you sought the truth in its purest form. People remarked that reading it felt like scaling a cliff without any safety ropes, but the view from the summit was unparalleled. By the early 1930s, Dirac was recognized as one of the key architects of modern physics. In 1933, he shared the Nobel Prize in Physics with Erwin Schrödinger. The pairing itself was poetic. Two individuals who had constructed different dialects of quantum theory now honored together. In Stockholm, Dirac delivered a lecture as concise as a theorem. He didn't express gratitude. He conveyed clarity. The audience respected him in the peculiar way people respect someone who refuses to pander to their expectations. And then a softer, unexpected chapter began in his life. Dirac frequently traveled to Copenhagen and met Margaret Wigner, Mansi, Sister Eugene Wigner, whom he had known from the European physics community. In contrast to Dirac, Mansi was warm, vivacious, and socially adept. She had a daughter from a previous marriage and a stability that didn't require Dirac to change. Their courtship was gradual and gentle, like a melody that emerges only after you stop actively searching for it. In 1937, they married. Friends were surprised. Some wondered whether the most taciturn man in physics could be a husband, but those close to him noticed a subtle shift. With Mansi, Dirac seemed less guarded. He still spoke sparingly, but he listened with a newfound tenderness, as if he had discovered a place where silence wasn't a punishment but a source of peace. Marriage also altered his daily routine. Dirac became a stepfather and later a father to two daughters, Mary and Florence. He was not an outwardly sentimental parent, but he was steadfast, patient, and quietly attentive. In family life, he displayed the same constancy he demonstrated in science. Once he embraced a responsibility, he fulfilled it without complaint. Meanwhile, Europe was sliding toward another catastrophe. Dirac, shaped by the aftermath of the First World War and now witnessing the rise of fascism, became even more detached from politics in public. He disliked ideological noise. Yet he wasn't oblivious. The scientific community he cherished was being torn apart by nationalism and persecution. Colleagues fled Germany and Italy. Jewish physicists were dismissed. The International Republic of Science was fragmenting into fearful islands. Dirac responded in his own way, by relocating. In 1935, he accepted a visiting position at the Institute for Advanced Study in Princeton, and although he remained affiliated with Cambridge, the United States became an increasingly significant part of his life. Princeton offered a different environment, less old world tradition, more new world ambition. There, he interacted with Einstein, who admired both Dirac's mathematics and his penchant for fundamental questions. Einstein once described him as the most logical thinker among the younger generation. Dirac, characteristically, accepted the praise without any visible reaction. During World War II, Dirac didn't participate in bomb projects like many of his peers. Instead, he worked on theoretical problems related to radar and isotope separation, but he avoided the Manhattan Project. Some interpreted this as moral detachment, others as a matter of personal disposition. Dirac was not suited for large teams, secrecy, or strategic planning. His mind functioned best in quiet rooms with a single, clear equation on the page. The war years also strained Cambridge and drew him closer to the American academic sphere. By 1945, the world had transformed once more. Quantum mechanics had become the central language of physics, and Dirac's contributions were foundational. Yet he remained unsatisfied. He still believed a deeper beauty awaited discovery, particularly in the effort to comprehend fields, particles, and the vacuum. He was increasingly concerned that quantum electrodynamics, then undergoing rapid development with numerous calculations, was becoming too convoluted, too reliant on mathematical artifices like renormalization. Dirac mistrusted fixes that felt inelegant, like a composer detecting a dissonant note. He felt that any theory requiring excessive patching was not yet the definitive version. So, Part 2 concludes with a man at midlife, renowned and Nobel laureate, married and still quietly restless. He has witnessed his equation give birth to antimatter, watched Europe disintegrate, and seen quantum mechanics evolve from a rebellious idea into the new orthodoxy. Yet within him, the old compass still points toward elegance. He is searching for a more refined future beyond the world's chaos, and that search will define the next chapter of his career. Part 3 will trace Dirac's journey after the war. His move to America, his later ideas about magnetic monopoles and quantum fields, and how his steadfast belief in mathematical beauty shaped physics, even as a community, began to lean toward more pragmatic strategies. After the war, physics entered a loud, practical era. Laboratories expanded, budgets increased, and computation became a new kind of intellectual force. The center of gravity shifted toward large collaborations and results that could be measured quickly. Paul Dirac, however, remained a man built for quiet rooms and long, solitary lines of thought. In the late 1940s and 1950s, this mismatch between his temperament and the new scientific culture became one of the defining tensions of his life. Not a tragedy, exactly, but a slow diverging of roads. He stayed at Cambridge for several years after 1945, continuing teaching and research. Yet he could feel in his bones that the theoretical world he had helped create was growing less elegant. Quantum electrodynamics was now producing astonishingly accurate predictions about electrons and photons, but the price of accuracy was renormalization, mathematical subtractions used to cancel infinities in calculations. To most physicists, renormalization was a triumph. It made the theory work. To Dirac, it felt like a confession of incompleteness. The universe, he believed, would not require ugly bookkeeping to remain finite. If a theory needed that much repair, then beauty was still waiting somewhere deeper. This belief did not make him popular on every front. Younger physicists hungry for practical success sometimes saw Dirac as out of sync, a great pioneer who had become too purist. But Dirac was not chasing popularity. He was chasing truth as inevitability. In his mind, physics without beauty was not yet physics. It was a temporary scaffold. In 1947, his work took a surprising turn into what might be called philosophical engineering. He began exploring the large numbers hypothesis, noticing eerie coincidences between huge dimensionless numbers in cosmology and atomic physics. Why did certain ratios, like the strength of gravity compared to electromagnetism, seem to be about the same order as the age of the universe measured in atomic units? Dirac suspected this was not accident but a sign of a hidden law. He proposed that some fundamental constants might vary slowly with cosmological time. It was a daring idea, one that many colleagues considered speculative, yet it showed Dirac's mind still working the same way. If beauty suggested a pattern, he followed it even when evidence was thin. A few years later, another of his lifelong fascinations resurfaced, the idea of magnetic monopoles. Classical electromagnetism allows electric charges, positive and negative, but no isolated magnetic charges. Magnets always come with two poles. But Dirac found that quantum mechanics did not forbid monopoles. In fact, the existence of even a single magnetic monopole anywhere in the universe would explain why electric charge is quantized in neat, identical units. He derived a simple relationship between electric and magnetic charge, the Dirac quantization condition. This work, elegant and compact, became one of the deepest, if then, statements in modern physics. If monopoles exist, then charge quantization is inevitable. Experiments have never conclusively found monopoles, but the idea remains a beacon in field theory, grand unification, and cosmology. Once again, Dirac had used beauty to plant a flag beyond current evidence. In 1959, at age 57, he made a major personal and institutional shift. He accepted a position at Florida State University in Tallahassee. To some, the move seemed surprising. Why leave Cambridge, the cathedral of his early glory, for a relatively young American department? The answer was partly practical and partly emotional. Cambridge had become too crowded with administrative obligation and too far from the kind of quiet autonomy Dirac valued. Florida State offered him freedom, light teaching load, and the chance to live a simpler rhythm with his wife Nancy. He was also increasingly tied to the United States intellectually, and the warmer, more open academic atmosphere suited his later years. Tallahassee was not a retreat from physics. It was a retreat from noise. He continued to publish, though more selectively. His lectures were famous for their clarity and severity. Students said he could fill an entire blackboard with a single derivation and make it feel like a poem carved into stone. But they also said he was intimidating in the particular way a truly precise mind can be intimidating. If a student asked a vague question, Dirac might pause, look mildly troubled, and then say something like, "That is not a well-defined question," end the conversation gently but completely. There was no malice in it. He just did not believe in rewarding confusion with comfort. Socially, he remained a puzzle. At Florida State faculty gatherings, he could sit through dinner with the same quiet that had defined his Cambridge years. Yet those who took walks with him or met him one-on-one often found something different. A man with dry humor, unexpected curiosity, and a sharp appreciation for simple pleasures. He loved hiking. He loved the piano. He loved children's innocent questions because they were often more direct than adult ones. With family, he was steady in the way a lighthouse is steady. He didn't move toward you, but you always knew where he stood. His marriage, in these decades, deepened into a kind of quiet companionship. Mancy understood his silences. She carried the social weight he never learned to carry comfortably, and she protected his solitude without turning it into a cage. Friends noticed that Dirac was gently more human around her, even if he would never become outwardly effusive. Their home was not dramatic. It was stable and quietly affectionate, the kind of love that doesn't need to announce itself. Back in the world of physics, however, the field kept sprinting toward pragmatism. The Standard Model was being assembled to the 1960s and 70s, an extraordinary framework of quarks, leptons, and forces. Dirac admired parts of it, but worried it was becoming too parameter-heavy, too empirical, too patched. He continued to hope for a more beautiful unification, perhaps through a deeper geometry or a more symmetric law. In talks, he sometimes sounded like a man from an earlier era, still insisting that elegance should be a guide rather than a luxury. Then there was his relationship with the public image of science. Dirac did not seek audiences. He rarely gave interviews, and when he did, journalists struggled to extract quotable drama. He had no interest in being a personality. Yet even without trying, he became a kind of legend. The silent saint of mathematics, the man who trusted beauty so much that beauty rewarded him with antimatter. The legend grew partly because of how others spoke about him. Colleagues circulated Dirac stories, the way sailors circulate stories about a lighthouse they once passed in fog. You didn't. Okay, I understand the instructions. Here's the translated and rewritten text, incorporating the interpret and clarify style with slight expansions for enhanced clarity. Dirac didn't always make immediate sense, but you always knew his words carried weight. A well-known story illustrates this. During a lecture, a physicist questioned Dirac's certainty about an equation's validity. Dirac simply responded, "It is more beautiful this way." For him, this wasn't a dodge, it was definitive proof. However, as the years progressed, Dirac also faced a solitude that came with unwavering consistency. The world of physics was vibrant with debate and trends. Dirac, in contrast, remained remarkably timeless in his approach. He never prioritized being right through consensus. His concern was being right through structural integrity. While this earned him admiration, it also increasingly distanced him from the prevailing currents of thought. He accepted this isolation with the quiet composure of someone accustomed to silence since childhood. If he harbored any complaints, he rarely voiced them. In the late 1970s and early 1980s, age began to take its toll. His gait slowed, his speech became even more economical, but his intellect remained sharp. He continued to refine his views on quantum field theory, still seeking a more elegant and fundamental basis. He occasionally attended conferences where younger physicists would gather around him like pilgrims around a sacred, quiet place. Part reverence, part sheer curiosity. What was it like to be the person who conceived the equation that unveiled antimatter? Dirac didn't offer anecdotes. He responded with concise, precise statements, as always. If asked about his achievements, he might simply say, "It was natural to do," before turning his focus to the chalkboard. Part 3 concludes with Dirac in his later middle age, residing in America, still guided by the compass of beauty as physics itself became more pragmatic, populated, and clamorous. He had seeded ideas that would outlive their tangible evidence, retreating to a quieter environment to maintain clarity of thought, and becoming a legend almost despite himself. The next part will delve into his final decades, his last academic appointments, his reflections on beauty and truth, his experiences with aging, and how the physics community learned to appreciate a man of few words who conveyed so much. The concluding decades of Paul Dirac's life unfolded with the unhurried dignity of someone who never adapted his pace for others. By the 1960s, he was a living legend, one of the principal architects of quantum theory, the author of the equation that unlocked antimatter, the serene intellect that had shaped the very language of physics. Yet within Dirac, fame didn't translate into complacency. It fostered a sense of detachment. He accepted accolades with the same equanimity he regarded the weather, as phenomena occurring independently of him, not as defining characteristics. At Florida State University, he discovered the rhythm that had always suited him. Tallahassee offered warmth, space, and distance from the congested prestige of Cambridge. He could teach, contemplate, and walk without the persistent buzz of past expectations. His lectures, they were understated. They were meticulous, pared down to the essentials. Students sometimes arrived anticipating a celebrity. They left having encountered a celebrated methodology. Dirac believed a lecture shouldn't entertain you into comprehension. It should guide you toward clarity, and if you couldn't follow, that wasn't a failure of charisma, but an indication that you needed to sharpen your thinking. Still, even Florida couldn't insulate him from the evolving culture within physics. The field had transformed into a high-energy endeavor. Particle accelerators, massive collaborative teams, vast streams of data, and theories forged through continuous interaction with experimentation. Dirac admired these accomplishments, but he felt uneasy about the shifting priorities. Physics, in his view, was becoming excessively practical, too ready to embrace complex structures merely because they aligned with observed results. He had dedicated his formative years to demonstrating that beauty could serve as a navigational tool toward truth. Now, he witnessed colleagues treating beauty as an optional embellishment. This was particularly apparent in quantum field theory and the Standard Model. The Standard Model functioned exceptionally well, predicting particles and interactions with remarkable precision. However, it also relied on numerous adjustable parameters, masses, mixing angles, coupling constants, determined empirically rather than derived from fundamental principles. To Dirac, this felt like a provisional compromise. He appreciated its accurate description of nature, but he couldn't accept it as a definitive account. A final theory, according to him, wouldn't just conform to the world. It would elucidate why the world had to be that way. Thus, in private notes and occasional publications, he persisted in searching for a more refined structure. One persistent theme was his ongoing reservations about renormalization. Even as the broader community embraced renormalization as an indispensable technique, Dirac maintained that it signaled incompleteness. He envisioned a reformulation of field theory that would be inherently finite, eliminating the need for infinite cancellations. He wasn't denying the empirical validity of QED. His point was that such success didn't equate to ultimate correctness. When younger physicists challenged him on this, he rarely engaged in lengthy debate. He would offer a gentle yet decisive statement, such as, "It is a question of mathematical beauty," and allow the ensuing silence to underscore the point. Another enduring focus was his fascination with symmetry. Dirac believed that nature's deepest laws were inscribed in symmetries we hadn't yet fully grasped. He followed the development of gauge theories with interest, acknowledging their elevation of symmetry from a mere convenience to a fundamental principle. Yet he also sensed that an even more unified framework lay hidden beneath the layers. He was particularly drawn to attempts to geometrize physics, to derive forces and particles from more fundamental mathematical spaces. In these concepts, he detected echoes of his lifelong aspiration. One equation, one elegant structure, no patchwork solutions. At times, he seemed isolated in pursuing this vision. The community had moved on, and Dirac was no longer at its helm. But he had never needed to be at the center to think clearly. He only needed the unwavering conviction that beauty wasn't a luxury, but a critical clue. That conviction remained as steadfast in his later years as it had been in his youth. Publicly, the world continued to celebrate him. Conferences extended invitations for him to be a guest of honor. Universities bestowed honorary degrees. Younger physicists treated him with a respect that verged on reverence. To them, Dirac embodied the proof that pure thought could transcend history. He accepted these acknowledgments in his characteristic manner, politely, succinctly, without any fanfare. At gatherings, his silences became legendary. There's an anecdote from a dinner in the 1970s where the room fell into an awkward hush, and someone asked Dirac if he was bored. He paused briefly and replied, "Boredom is a function of poor imagination." The statement was quintessential Dirac. Concise, calm, subtly cutting, and quietly humorous. On another occasion, after a lengthy and complex seminar, Someone inquired about his thoughts. Dirac responded, "It is not sufficiently beautiful." Nothing more. The speaker was devastated. But years later, some conceded that Dirac's remark had compelled him to strive for a more elegant formulation. Behind the public persona, his personal life remained simple. He and Mansi lived modestly. He walked frequently, enjoyed the outdoors, and continued to play the piano. He enjoyed travel in an understated way, visiting places without needing to be overwhelmed by them. With family, he was dependable and kind. He wasn't expressive in the conventional sense, but he was reliable in a manner more uncommon than mere expression. His daughters remembered him as a father who would take them on long walks, answering their questions not with patronizing tones, but with genuine respect for their curiosity. During these years, Dirac also carried a quiet sorrow. His older brother, Felix, had died by suicide in 1925, leaving a wound that remained largely unspoken. In Dirac's family, intense emotions were dealt with privately. That early loss may have deepened his reserve, but also imbued him with an underlying empathy for silent suffering. He never flaunted his own pain, but those who knew him well sensed that his silences sometimes contained more than just logic. As he aged, his health began to gradually alter the rhythm of his days. His movements slowed. His extended walks became shorter. He traveled less frequently. Yet he retained a mental acuity that astonished visitors. Even in his late 70s, he could examine a chalkboard and reshape an entire argument with a single, elegant stroke. He remained, at his core, a man who lived to think. A scene from the late 1970s encapsulates his character perfectly. A young physicist, both excited and apprehensive, asked Dirac if he thought new experimental discoveries might overturn quantum theory. Dirac paused. He disliked speculation unsupported by structure. Finally, he said, "Quantum mechanics is good, but it is not yet perfect." Then he added, almost tenderly, "We must look for a more beautiful theory." In that moment, you can hear the same voice that authored the Dirac equation: confidence in the present, faith in a more elegant future, and a refusal to yield to ugliness simply because it works. By the early 1980s, Dirac was increasingly becoming a figure of memory within physics. The field had exploded into new frontiers: core confinement, electroweak unification, nascent string theories. His style didn't align with those emerging trends. He could appreciate their ambition, but he didn't pursue them. He preferred to allow ideas to mature slowly, to follow symmetry wherever it felt inevitable, and to trust that a final theory would eventually manifest in a form so simple it would feel as though it had always been there. Part 4 concludes with Dirac nearing the twilight of his life. Still in America, still guided by beauty, still honored but increasingly removed from the bustling mainstream of his field. His life has become quiet not because he is diminishing, but because he has always inhabited a realm of quietude. The final part will trace his last years, how he confronted mortality, the legacy he imprinted on the language of physics, and why his equation remains one of the most elegant bridges ever constructed between thought and reality. In the final years of Paul Dirac's life, time appeared to move in opposing directions simultaneously. The world around him accelerated. New particles, new machines, new theories ascending like scaffolding toward an unknown summit, while his own days slowed into a serene, almost monastic cadence. He wasn't one to make a spectacle of aging. He simply entered it as he would approach an equation, without complaint, with attention to structure, and with an unwavering refusal to misrepresent anything as either more or less than it truly was. By the mid-1980s, Dirac had formally retired from most teaching responsibilities at Florida State University, though retired was hardly an accurate descriptor for him. He continued to visit the campus. He still attended seminars when his health permitted. He still read research papers with a pencil in hand, as though the universe might finally reveal a more refined form if one scrutinized it patiently enough. Visitors frequently remarked on his enduring mental sharpness, even as his physical form grew frail and weary. If you placed a chalkboard before him, the familiar clarity would resurface. His eyes would narrow slightly, not from strain but from intense focus, and he would correct a line of reasoning with a few strokes that seemed akin to smoothing a wrinkle from fabric. Those who had known him for decades observed that his silences deepened rather than widened. He spoke even less, But when he did speak, his words carried the same quiet authority they always had. He wasn't attempting to be enigmatic. He was simply unwilling to lend weight to words that didn't warrant it. In a culture increasingly driven by rapid communication and hasty publication, Dirac's economy with words began to appear almost subversive. To him, it was simply a matter of moral integrity. During these years, he also became increasingly aware of how the physics community had transformed his name into a kind of vocabulary. Dirac delta, Dirac spinor, Dirac C, Dirac notation, Dirac equation. Students use these phrases as readily as they use gravity or energy, seldom pausing to imagine that a human being had once sat in a small room in Cambridge and conceived them. When Dirac overheard his own name being used in this way, he didn't become boastful. He appeared mildly amused, sometimes slightly bewildered. He didn't feel possessive of ideas in a sentimental way. If the ideas were correct, they belonged in nature itself. Yet he cared deeply about one thing, the standard of beauty that those ideas exemplified. In later interviews and in frequent remarks, he consistently returned to the same conviction that had guided his youth. A final theory of physics, he asserted, would be beautiful. Not beautiful in a decorative sense, but beautiful in a way a simple, inevitable structure is beautiful. He worried that too many physicists had become content with successful complexity. He didn't condemn them. He understood the allure of fitting data, but he feared that abandoning the pursuit of elegance meant forfeiting the best guiding principle science possessed. There was an almost touching stubbornness in this belief. Dirac wasn't dismissing the standard model or quantum field theory. He was refusing to accept them as a final word. He believed the universe possessed a more refined grammar than the one currently being used. Some colleagues interpreted this as being outdated. Others viewed it as prescient. Regardless, he maintained his position without animosity. He was a man who could accept being out of sync, because being out of sync had been his natural rhythm since childhood. Outside of physics, his life remained remarkably uncomplicated. He and Mancy lived quietly, their home filled more with routine than with fanfare. She continued to serve as a social bridge, the person who could translate his silences into warmth for visitors and family. Dirac, in turn, offered her unwavering stability. Friends described their marriage during these years as a kind of tranquil harbor. Not dramatic, not noisy, but profoundly reliable. If Dirac was a man who rarely expressed affection overtly, he consistently demonstrated loyalty, and for Mancy, that was a form of love that needed no embellishment. His daughters and grandchildren were now adults, and he took quiet pride in their lives. He was never the kind of grandfather who engaged in playful antics, but he enjoyed being asked genuine questions. Children didn't tease him for being quiet. They accepted quiet as normal. In that space, he could be surprisingly gentle. He would answer a child's curiosity with the same precision he gave a physicist, minus the severity. In later family recollections, this emerges as one of the most human portraits of him, an elderly man walking slowly along a path, providing a child with concise yet illuminating answer, and then reverting to silence as if silence were the most natural state of being. In 1984, Mancy's health began to deteriorate, and Dirac's own world contracted further. He had never been demonstrative, but those close to him sensed how much he depended on her presence. When she was fatigued, he grew quieter, not in withdrawal, but in a kind of protective attentiveness. Their companionship, already characterized by quietude, became visibly more precious. For Dirac, who had grown up with silence as a form of punishment, it was a quiet irony that his greatest peace in life had come through sharing silence with someone who loved him. His own health, too, began to decline in small, unspectacular increments. He walked more deliberately, traveled less frequently, and attended fewer conferences. But even when confined to his home, he continued to think. His notebooks from his later years reveal him still exploring variations on field theory, still grappling with infinities, still questioning whether a different symmetry might unlock a deeper order. The work was no longer fueling a revolution as it had in the 1920s, but was the same fundamental act, trusting structure sufficiently to persist in seeking it. In 1984, on one of his last trips to Europe, Dirac visited Cambridge. The familiar courtyards were unchanged, but Cambridge now felt different to him. like a place belonging to an earlier version of himself, a self that had walked with greater speed and stood closer to the genesis of modern physics. Colleagues noted that he seemed contemplative but not sentimental. He didn't romanticize the past. He viewed it as he viewed a derivation, as a chain of steps, each essential at the time, each leading to the next. In October 1984, Dirac was in Tallahassee when he suffered complications that led to his death on October 20th. He was 82 years old. The news rippled quietly through the physics community at first, and then expanded into a deeper, more sustained mourning. It wasn't the mourning of a celebrity. It was the mourning of an architect whose blueprint had become the building everyone inhabited. Following his death, tributes frequently focus on the Dirac equation, and rightly so. That single line of mathematics had fused relativity and quantum mechanics for spin, one-half particles, predicted antimatter, and established a foundation for contemporary particle physics. But those who were familiar with Dirac's broader body of work remembered something else equally significant: his way of thinking about what constitutes a valid theory. Dirac didn't believe that truth was merely a matter of conforming to data. He believed that truth possesses shape, a symmetry and inevitability that could be intuited even before it was empirically confirmed. This belief was audacious, but in his case, it repeatedly unlocked possibilities that others had overlooked. His influence also endures in the language of physics. Bracket notation provided quantum mechanics with a shared vocabulary. The delta function he employed and systematized became a ubiquitous tool across science and engineering. His quantization condition for monopoles continued to guide theoretical investigations long after his voice had faded. In these ways, Dirac's legacy wasn't merely a collection of findings, but a style, minimalist, structural, and unwilling to accept ugliness as the final answer. There's a subtle moral thread woven into that style. Dirac didn't proselytize. He didn't engage in advocacy. But by living as he did, by refusing to sacrifice elegance for expediency unless nature compelled him to, he imparted a lesson about patience and standards. He demonstrated that science can be an act of faith. Faith that reality is coherent enough to be described elegantly, and faith that human minds can glimpse that coherence if they are willing to listen for it in silence. If Part 5 evokes a feeling, it's the feeling of a shoreline at dusk. Dirac's life wasn't a dramatic arc. It was a steady river that sometimes carved through rock so smoothly that you only notice a canyon afterward. In the end, he didn't leave behind a tale of drama or confession. He left behind a language for the universe, one that still feels, nearly a century later, remarkably spare and true,